Okay, this is your question. The motion of a particle is described by x equal to 2 into t plus 1 the whole square and y equal to 2 by t plus 1 the whole square. Show that the path traveled by the particle is rectangular hyperbola. Find the velocity and acceleration of the particle at t equal to 1 second. Okay, take down the question. Okay, fine. So we will see the question. The motion of a particle is described by x equal to 2t square plus 1 and y equal to 2 by t plus 1 the whole square. So this is the relation of x and y. Now what you have to find is show that the path traveled by the particle is rectangular hyperbola. So first part is this, that is you have to show that the path traveled by this relation. Okay, the particle is moving like this, and you have to find or you have to show that the path traveled is rectangular hyperbola. How we'll see whether a particle traverses a parabola, rectangular hyperbola. It's nothing but just multiply the values x and y, the terms x and y, and if you are getting a constant value, suppose x into y, you are getting a constant value without any variables, then we can say it is a rectangular hyperbola. Okay, I'm not going in depth to that, but just understand that. That is x into y. Here, if you multiply x into y, then you will get 2 into t plus 1 the whole square into 2 by t plus 1 the whole square. This t plus 1 the whole square and t plus 1 the whole square will be cancelled. Then you will get the value 4, which is a constant. So hence we can say, hence the path traveled, by the particle is rectangular hyperbola. Okay. So the first part is over. Now you have to find the velocity and acceleration of the particle when at t equal to 1 second. Okay, so we will see. Suppose you are given the value of x and y. First of all, what you have given is the displacement. That is a displacement vector, vector r. Displacement vector r is xi plus yj. This is displacement vector. If the displacement is given, then the velocity is given by velocity vector v is given by dr by dt. So it is dx by di, like that. Before that, we have to substitute these values. Instead of x, 2 into t plus 1 the whole square I, plus instead of y, 2 by t plus 1 the whole square, 2 by t plus 1 the whole square j. So this is vector r, or the displacement vector. When you get the displacement vector, from that you can find the velocity vector as vector v equal to differential of that. That is differentiating each term. Differentiating 2 into t plus 1 the whole square, you will get 2 into 2, that is 2 into this 2 into t plus 1 the whole raised to 2 minus 1, this much I, plus what is the differential of 2 by t plus 1 the whole cube? Minus 4 by t plus 1 the whole cube. How it will come? That is just a rough part. 2 by t plus 1 the whole square. You can write as 2 into t plus 1 the whole raised to minus 2. Then if we are differentiating d by dt, you will get 2 into minus 2 into t plus 1 the whole raised to minus 3. That is minus 4 by t plus 1 the whole raised to 3. So here it is. Minus 4 by t plus 1 the whole raised to 3 j. This is velocity vector, and if we get the velocity vector, from that we can find the acceleration vector a by differentiating velocity. So dv by dt, that is again differentiating, that is here it is 4 into t plus 1. By differentiating, you will get it as 4i minus, here again minus 3 into 4, that is 12, that is plus 12 by t plus 1 the whole raised to 4 j. So you got the vectors for displacement, velocity and acceleration. Now you will find the values where t equal to 1 second. When t equal to 1 second, you have to find the velocity and acceleration. So at t equal to 1 second, at t equal to 1 second, what happens? Vector r equal to, substitute the values for t equal to 1, and you will get 8i plus 0.5 j. Now vector v equal to 8i minus 0.5j, and vector A equal to 4i plus 0.75j. So first of all, we have found the vectors of the displacement, velocity, and acceleration. After that, we have substituted the value for the time, that is t equal to 1 second. Then we have reduced the vector to this particular value. Now we have to find the magnitude of velocity and acceleration. It is being asked in the question. That is, find the velocity and acceleration at t equal to 1 second. So magnitude of velocity, therefore velocity comma v equal to root of the components of the velocity, squares of the components of velocity, that is 8 square plus minus 0.5 square, that is 8.02. You will get the value as 8.02 meter per second. This is the velocity, and acceleration is a equal to root of the component square of acceleration, that is 4 square plus 0.75 square, and you will get the value as 4.07 meter per second square. So these are the final value. Okay. So in the question, the first part is you have to show that the path traveled is rectangular hyperbola. For that, you have to multiply x and y, and you will get a constant value independent of the value of t. Here there is no t, only a constant, that is 4. So you can say the path traveled by the particle is a rectangular hyperbola. Then after that, you have to find the velocity and acceleration. For that, you have to find the vectorial notation first, then convert it into or apply the value of time, then find the magnitude. Okay, just do that. Okay, so completed. Is it completed? So shall we move to next question? Please unmute and say, because my chat box is not working. Shall we continue? Okay, anyway, so take down the values. Next question. A car starts from rest on a curved rod of radius 600 meter and occurs by the end of the first 60 seconds of motion a speed of 20 kilometer per hour. Sorry, 24. Find the tangential and normal acceleration. Find the tangential and normal acceleration at the instant at the instant t equal to 30 seconds. So take down the question. Okay. This is your question. A car travels from rest on a curved road of radius 600 meter. So the radius 600 meters and occurs at the end of first 60 seconds a speed of 24 kilometer per hour. So initially the car was at a point 1. Let this be the point. Then after that, suppose it moved to a point like this. Okay. Okay. So this is the motion. So initially this was the point, and finally it reaches the point 2. So the time taken, you can consider okay. So this is the initial point and the final point. So the time taken to reach 2 is, that is T12, is given as 60 seconds, right? So after 60 seconds, the motion, it attained a speed of 24 kilometer per hour. So initially it starts from rest. That means at 1, the value of V is 0. That is V1 equal to 0. And here it is V1 acting. So V1 will be acting in the tangential direction. So this is V1. This is linear velocity, and the angular velocity will be like this. That is omega 1. And here the linear velocity will be in this particular direction. That is V2, and the angular velocity omega 2. Okay. The time taken is T12. So initially the car is at rest. So V equal to 0, and also omega which is R into or V by R. So omega is also 0. Omega 1 equal to 0, because initially at the point 1 it is 0. Then it moved to the point 2, and after 60 seconds the velocity becomes V2 becomes 24 kilometer per hour. So make it into meter per second. That is 24 into 1000 by 3600. This much meter per second. Okay, this is velocity V2. Now after 60 seconds, V2 becomes this particular value, and so we will find the value for omega 2. Omega 2 will be V equal to R omega. Therefore omega equal to V by R, V2 by R, which is this particular value, that is 24 into 1000 by 3600 into 1 by R, that is 1 by 600. Then you will get a value 0.011, that much radian per second angular velocity. So you got the value for angular velocity. Now what is being asked? Find the tangential and normal acceleration at the instant t equal to 30 seconds. So here 1.1, it is t equal to 0 seconds, and point 2 is t equal to 60 seconds. So t equal to 30 seconds means it is somewhere between 1 and 2. So let us say this is that point, and we give the name 3, where t equal to 30 seconds. So we have to find the tangential and normal acceleration of the point 3. Okay, at the point 3 we have to find the values for at and an. So here we can consider, just for a reference purpose, we are considering a line. Okay, and the angular velocity over there will be omega 3. Okay. Now, in order to find that, that is t equal to 30 seconds, at that time, we have to find the value for tangential and normal acceleration and the relation. What is the relation for tangential acceleration? Tangential acceleration at is given by dv by dt, or it is r alpha, and for the normal component an equal to omega square r or v square by r. These were the relations. Okay, so you have to you have already got the value for r. You are having 600. Alpha you have to find out. Okay, omega also you have to find out using this relations. So omega 3 you have to find, because we have to find the value for at and an at the point 3. Okay, so first of all, the alpha will be common to all case. So in order to find the value for alpha, we have got 3 relations. What were the relations? That is like the relations v equal to u plus at, s equal to ut plus half at square, and u square equal to v square equal to u square plus 2as. Alternately, you are having the relations like omega 2 equal to omega 1 plus alpha t, one relation. Then theta equal to omega 1 t plus half alpha t square, t12 square. Then omega 2 square equal to omega 1 square plus 2 alpha t not t, theta 2as, right? Okay, so you have these relations. So use any of these relation to find the value of alpha. So which relation you can use? Connecting 1 and 2. You can use this relation, first relation itself. So you pick that relation connecting the 2 and 1, that is omega 2 equal to omega 1 plus alpha t12. Omega 2, you know, it is 0.011, and omega 1 is 0 plus alpha into t12. T12 is 60 seconds. So from there you will get the value of alpha as 0.00018 radian per second, square. Okay, so you got the value for what you call radian per alpha. Now you will consider the motion, that is the motion to 3, from 1 to 3. So you are having these relations. So the relation connecting 1 and 3 you can write in another way, that is here initial value is 1 and the final value is 3. So the relation will be like, instead of 2 will be 3, and here also every value will be changing, like this is 3, this is 3. Okay, so using any of these relations, what you have to find is the omega 3 you have to find. So the relation connecting omega 3 is the first and third one. From that, which one will be using? Yeah, first one, because we don't know the value of theta. So the first one we are using. So omega 3 equal to omega 1 plus alpha T13 implies omega 3. You have to find the value of omega 3. So omega 3 equal to omega 1. Omega 1 is 0 itself, plus alpha. Alpha, now you got the value 0.00018 into T13. T13 means time taken to reach the point 3 from 1. That is 30 seconds, right? So 30 seconds into 30. So the value is 0.0055 radian per second. This is omega. Next, now we have to find the values, that is AT. Now we can easily find the values of AT and AN. Just substitute. So the tangential component of acceleration AT is given as r into alpha, which is equal to 600 into alpha is 0.00018, which is 0.108 meter per second square. Unit is important. This is linear acceleration, the meter per second square. If it is angular, then radian per meter square. Sorry, radian per second square. Then normal component of acceleration given by normal component omega square r, or v square by r. But here you are having the values omega 3 square into r, which is equal to, why we are using omega 3? Because it is asked to find the acceleration components at the point where the time is 30 seconds. So the point at 30 seconds is omega 3. So we are taking omega 3, and the value is 0.0055 square into r, which is 600, and you will get the value 0.018 meter per second square. So these are the final values. Okay. So just note down the values. Please mute the mic. Okay, have you completed? Please respond in the chat box. So shall we move to next question? Yes or no? Okay, fine. A car starts from rest on a curved road of 250-meter radius, 250-meter radius, and accelerates at a constant tangential acceleration of tangential acceleration of 0.6 meter per second square. 0.6 meter per second square. Determine the distance and determine the distance and the time for which that car will travel before the magnitude of the total acceleration attained by it becomes 0.75 meter per second square. Okay, so this is your question. The figure is not given. The figure we are going for the solution part. Okay. So completed the question. So a car starts from rest. So here also the car starts from rest on a curved road of radius r is given 250 meters and accelerates at a constant tangential acceleration. Constant tangential acceleration, that is tangential acceleration at, which is constant. Constant means at point 1, 2, etc., or at any intermediate point the value of at will be same. So at value of at is same here, here and also here. Okay. And the value is given as 0.6 meter per second square. Now determine the distance and time for which the car will travel. Distance, that is distance s you have to find. Then the time t for which the car will travel before the magnitude of total acceleration attained by it becomes 0.75 meter per second square. So you have to find the distance, how much distance it will move when the value of a, total acceleration a equal to root of a means the resultant of normal and acceleration, normal and tangential acceleration, at and an. Using at and an, you have we have already found the value for a, that is a equal to root of at square plus an square, right? So that value, when it becomes 0.75 at that particular time, what is the distance traveled and also the time that you have to find. Okay, so we will see what are the given parameters. This is the initial point and this is the final point. So here the angular velocity omega 1, here the angular velocity is omega 2, and what you have to find is the time required to move from 1 to 2, that is t12 you have to find. What all things are given? Car starts from rest though, so you can write omega 1 equal to 0 because it starts from rest, 0 reading per second. Then the radius is given as r equal to 250 meters and it accelerates with a constant acceleration, constant tangential acceleration, that is at is given as 0.6 meter per second square. Okay, and you have to find the value of the time and distance, that is yes you have to find, and also time t12 you have to find. Okay, there the value of a is 0.75 meter per second square. Okay, at this point we have to find the values of s and t. So we'll see how we can make this. So you know the value a is nothing but root of at square plus an square, or you can write a square equal to at square plus an square, and from there an equal to, or an square equal to a square minus at square, or an will be root of this much, and you will get the value as, that is a n equal to root of a square minus at square, or it is a is 0.75 square minus 80 is 0.6. So you will get the value 0.45, 0.45 meter per second square. This is the value of an at the point 2. Here the value of an, that particular value is given 0.45. Now what is the relation for an, usual relation for an? Actually an is, that is, but an equal to an equal to omega square r. So it is 0.2. So omega 2 square into r. So from there we can find the value of omega 2. Like an is 0.45 is equal to omega 2 square into r. R is 250. So from there omega 2 equal to, you will get 0.0424, that particular radians per second. Okay, this is omega 2. Now now you have to find the value of S and T. So in order to find that, you have used the relation for an. First of all, you are using the relation for an. From there you got the value for omega 2. Now for AT, the relation was, usual relation for AT was R alpha, R into alpha, that will be alpha 1 2. From there you can find the value for alpha, that is AT is 0.75, which is equal to 250, R equal to 250 into alpha, which implies alpha 1 2 equal to 0.0024 radian per second. Okay, radian per second square. So you got the value for omega, alpha. Now from there you can easily find the value of T, that is using the relations. Which all relations you have? That is omega 2 equal to omega 1 plus alpha 1 2 T12, then theta equal to, is equal to ut plus half a t square, that is omega t plus half a t square, half instead of a alpha 1 2 t square, then omega 2 square equal to omega 1 square, that is b square equal to u square plus 2as, that's 2 into, instead of a alpha 1 2, instead of s theta 1 2. So you have these relations. From there the first relation, omega 2 equal to omega 1 plus alpha 1 2 into T12. Using this, you can find the first value, that is T12. That is omega 2 is 0.0424 equal to omega 1. Omega 1 is 0 plus alpha 1 2 is 0.0024 into T12. From there you can find the value for T12 as T12 equal to 17.67 seconds. Now we have another relation, that is we have another set of relations we had, that is S equal to r theta v equal to r omega, and velocity acceleration a equal to r into alpha, where s is the linear displacement, theta is the angular displacement, v is the linear velocity, omega is the angular velocity, a is the linear acceleration, alpha is the angular acceleration. So the first relation, that is s equal to r into theta. So here we have to find the value of theta, then only you can find the value of s. So first of all we have to find theta. For that we may use the relation for the theta, that is this second relation, that is theta or theta 12 equal to theta 12 equal to omega 1 t12 plus half into alpha 12 t12 square. Now omega 1 equal to 0 plus half into alpha is 0.0024 into t12 17.67, and you will get the value as 0.375 radian. Okay, now using this just substitute the value for s, that is therefore s equal to r into theta 12, which is equal to rs 250, so 250 into 0.375, which is 93.75 meters. So this is the final answers. So these are the final answers, that is T12 and T12 time required, and also the distance 93.75. Okay. So take down the answers. So completed. I think just I will mention once more. So this was the question. The car starts from rest. So it starts from the rest. So omega equal to omega 1 equal to 0, and the radius is given 250 meters. It is given that there is a constant tangential acceleration. So acceleration t, at, the component at is same for 1 and 2. That is 0.6 meter per second square. Now you have to find the distance and the time for which the car will travel before it reaches the total acceleration. Total acceleration is a, which is root of at square plus an square. This particular value will become 0.75. That is the point 2. At this point 2, the acceleration a is this value. So we'll consider the point 2 and find an, out of which you get 0.45 meter per second square. And we connect this to the usual relation, that is omega square r, and we found the value for omega 2. And after that, using the relation for at, you found the value for alpha, and using the values omega 2, alpha, etc., using the relation omega 2 equal to omega 1 plus alpha t, you found the value for t12. And after that, using the other relation for theta, you found the value for theta and substitute in this particular relation, and you got the value for distance also as 93.75 meters. So these are the final answers. Okay, so shall we move to next question? Okay, good. A car enters a curved portion of a road in the form of a quarter of a circle of radius 100 meter at 18 kilometer per hour. And leaves at 36 kilometer per hour. If the car is traveling with a constant tangential acceleration, find the magnitude and direction of find the magnitude and direction of find the magnitude and direction of acceleration when the car first one enters and second one leaves the curved portion of road. This is the question. Please take down. So finish the question. So this is your question. A car enters a curved portion of a road in the form of a quarter circle of radius 100 meters. So a car, suppose a car, it enters a curved portion. So this is a curved road, total curved road, and enters a curved road like this. This is the entry. Here it enters, and it moved our curved portion in the form of a quarter of a circle. That is, this is the full circle is like this, and the quarter circle is like this. Okay, so a quarter portion it has covered, and the radius is given as 100 meters. And so you can see this is the radius. Radius is given, that is 100 meters, and it enters at 18 kilometer per hour. So this is the velocity. Velocity, it will be tangential, that is v1, 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 and it is given as 18 kilometer per hour, 18 kilometer per hour, sorry, hour, and leaves at 36 kilometer per hour. So this is the final point. So it is leaving at a velocity that is v equal to, or v2 equal to 36 kilometer per hour, 36 kilometer per hour. If the car is traveling with a constant tangential acceleration, so the tangential acceleration is constant value, find the magnitude and direction of the acceleration when it enters and leaves the curved portion. That is, when it enters, enters means this point, that is, here is the entry point, entry point, and this is the exit point, or here it leaves here. Okay, so this is the entry point and this is the exit point. So at these points, find the values of a. So a value of a you have to find. Okay, so what are the given parameters? First of all, the radius is given, radius r is 100 meters given. Then the velocity at the entry point, that is v1, it is 18 kilometer per hour. So in order to make it into meter per second, 18 into 1000 by 3600, this much meter per second, that is 5 meter per second. Just a minute. Okay, this is v1. Now v2, velocity at the exit, it is 36 kilometer per hour, which is 36 into 1000 by 3600, sorry, which is 10 meter per second. Now, using the values of V1 and V2, we can find omega 1 and omega 2. So, this is omega 1 and this is omega 2. And the angular displacement it is theta equal to 90 degree because it is quarter circle. But we have to use the radians. How to convert a degree value into radian? Degree value into radian. How we are converting? Multiply by pi by 180. Okay. Into pi by 180, you will get the value as a radian. So theta value you don't put like 90 degree, but theta equal to 90 into pi by 180. That is approximately pi by 2 radians, that much radians. Okay, this will be the value for theta. Let it be like this. Okay. Anyway, then now using V1 and V2, we find the value for omega. So omega 1 equal to V1 by R, that is pi by 100, which is equal to pi by 100 equal to 0.05 radian per second, and omega 2 equal to V2 by R, that is 10 by 100 equal to 0.1 radian per second. Now we have the relations for AT and AN as AT equal to R alpha and AN equal to omega square R. Now individually at the each point, the point where the car enters, so at entry point that is point 1, there omega 1 is 0.05 radian per second. We have arrived at that, and R equal to 100 meters. So from that we can find the value for AN equal to omega 1 square into R. That is the relation for AN. This substitute and you will get 0.05 square into R, that is 100. That is 0.25 meter per second square. Similarly, for the point 2, that is the exit point, or you can say at the point where the car leaves, that is the point 2. there the value is omega 2 equal to 0.1 radian per second, and r equal to 100 meters. So from there an equal to omega 2 square r, which is equal to 0.1 square into 100, which is equal to 1 meter per second square. So in the 2 points we get the value of an. Now we have to find the value of at which is common for 1 and 2. There you have to find the value of alpha. So in order to find the value of alpha, you will consider the relation like omega 2 square equal to omega 1 square plus 2 into alpha 1 2 into theta 1 2. Okay, so which implies omega 1 2 is 0.1, so 0.1 square equal to 0.05 square plus 2 into alpha 1 2 into theta 1 2. Theta 1 2 should be in radians. Actually the angle is 90 degree, but you have to convert it into radians. So into pi by 180, this is theta. So from this we can find the value of alpha 1 2 as, you will get the value as 0.00239, this much radian per second square. Now using these relations you can find the value at, which is r into alpha 1 2, which is 250 sorry 100 into alpha, that is 0.00239, which is equal to 0.239 meter per second square. Okay, now so the values are, the first case that is when car enters the curve. So when the car enters the curve, what all things happens? There is a value of tangential acceleration. Tangential acceleration is now just you have found, that is 0.239 meter per second square, and the normal acceleration is an equal to 0.25 meter per second square. So using this you can easily find the value of a as a equal to root of at square plus an square, which is equal to root of 0.239 square plus 0.25 square, which is equal to 0.3459 meter per second square. This is the value of acceleration. Now you have to find the direction also, in which direction it is acting. So for that you have to see the figure. The acceleration is always, the tangential acceleration is always acting in this particular direction, the same direction of the velocity. So at the point 1 we can consider the direction of acceleration as like this, that is this tangential acceleration at, and the normal acceleration is towards the center point. So the normal acceleration will be in this particular direction, an. This is for the point 1. Now for point 2, here the tangential acceleration will be in this particular direction, that is tangential acceleration at, and the normal acceleration will be downwards, an will be like this. Okay. So point 1, that is an acting in this particular direction, at is acting vertically upwards. So here we consider the acceleration. That is, here it is an, normal acceleration, and this is at. Then the resultant acceleration, that is a, which is 0.3459, which will be acting at an angle. Let this be theta 1. Then theta 1 will be equal to tan inverse of y by x, right? Y term is at. So at by x term is an. So this is theta 1. So this is tan inverse, it is 0.239 by 0.25, and you will get 43.71 degrees. Okay, so this is the case for when car enters the curve. There the value of at is 0.239, an is 0.25, and you found the resultant acceleration, that is 0.3459, and the direction was like this. Okay. Now the second case, that is when the car leaves the curve. Then the car leaves the curve or the road. Okay, curved road. What happens? When it is leaving, then the acceleration is acting. The tangential acceleration will be along the tangential direction, that is along this direction. This is the tangential direction. Then the normal component of acceleration towards the center, that is in this particular direction. So at and an, so we can represent in the figure. At, this is at, and this is an, and the resultant acceleration a. The angle between the horizontal and the resultant, we take it as theta 2. Then theta 2 will be tan inverse of y component is an by at. So before that, we will find the value of a. So here in the second case, at equal to at is 0.239 itself, because it is constant. And an here it is, when leave the curve, an value is 1 meter per second. So 1 meter per second square. Now substituting the values, a equal to root of at square plus an square equal to root of 0.239 square plus 1 square, which is equal to 1.0282 meter per second square. Okay. Now the direction theta 2 is given by tan inverse y component, it is an, and the x, it is t. This is tan inverse 1 by 0.239, and you will get as 76.56 degrees. So these are the final answers. Okay, so once again, this was a problem. So the car enters a curved portion like this in the form of a quarter circle. Quarter circle means 1/4 of a full circle. So the angle we know it is 90 degree. This is the point where it enters, and this is the point where it leaves. So at the entry point, the velocity was 18 km/h, and at the exit point, the velocity was 36 km/h. So we made it into meter per second, and we got the values. And using the values of v1 and v2, we have found the value for omega 1 and omega 2, that is 0.05 and 0.1. Now the relation for AT and AN is like this. AT is, or the tangential component of acceleration, is r alpha, and normal component is omega square r. Now we don't know the values for alpha and omega, so we have to find omega we know, but we don't know the value of alpha, so we have to find the value for alpha in order to find the value of AT. Otherwise you can find the value of AN. So first of all, we found the value for AN at the 2 points using these relations. So at the entry point, the value of AN, we got the value as 0.25, and at the exit point, using omega 2 and r, we found the value of AN. Now in order to find the value of AT, which is common at 0.1 and 2, you have to find out the value for alpha. So in order to find the value for alpha, you have used the relation omega 2 square equal to omega 1 square plus 2 alpha theta, and for that theta is to be given. And one thing you have to keep in mind is theta should be in radian. So you have to convert 90 degree into radian. For that you have to multiply by pi by 180. So 90 into pi by 180, and substitute in this relation, you will get the value for alpha. And using the value of alpha, you found the value of AT. Now just substitute the values and find the values for AT for both the cases, and we will consider the individual cases and found the value of acceleration out of it and the direction. So the final answers are like this. Okay, so I think you have completed. Okay. So let us take the attendance.